Dr. Werner Vogels.
Good morning, Las Vegas. I hope you all survived the pub crawl from last night. Yeah, did you? Was it fun? You can get some. By the way, I did quite a few of the stations last night, and I don't know who I met, but if someone can explain to me why I ended up with these 2 black casino chips, I would be very much appreciated. Yeah? So I'm going to be your MC for this morning. Basically, if you know, is the reinvent is the hashtag for you to follow. If you have direct criticism in any form, yeah, you can skip the hashtag and just send it to me directly on Twitter. So I hope that this morning you will remember some of the really cool stuff that we'll be talking about, but not much about me. What's really important is that we'll have a number of customers on stage today that will tell you great stories about how they're using the AWS technology. And we'll also have a demo and hopefully some cool announcements for you to enjoy. I'm going to pick up where Andy sort of left up yesterday, Andy Jassy in his keynote, about our pace of innovation, which I think is really important and is one of the key differentiators that sets AWS aside for many other providers. And you know, this year already 243 major announcements, major services and features delivered to you, and I'm pretty sure that 6 weeks from now, this number will be a lot higher, and we'll be exiting with a number of really, really major changes. And of course, some of these things are really big, like the things that Andy announced yesterday, Amazon Workspaces and Amazon AppStream are just major things that will rock the industry. But if you look at the other 443 announcements, yeah, there were many smaller things, so things that look smaller. And some of you even have told us that you're getting kind of confused about all the stuff that's happening under the covers and all the things that we are delivering for you. And actually, I think we delivered some really, really cool stuff that may not make the top of the list. One of my favorites in this list, for example, is the new JavaScript SDK. Where you can build applications that can access the AWS services directly from your browser. So what you do is you just write some JavaScript, you dump it in an S3 bucket, you put in your cross-origin scripting configuration in there, and immediately you have an app that you can launch in any browser, anywhere in the world. So that's really cool. And so this whole rapid delivery stuff is 2D in our DNA. Obviously, you can imagine that with so many announcements, just like Amazon.com, we are going to consider actually launching services on Sunday as well. So, how do we decide what to do, what to launch? Is there a great master plan in action when you look at all of these launches? And for us, what's really important is that we build the exact features that customers, that you really need. And we have a very specific development methodology in place there. It's called working from the customer backwards. And this has a number of very clear steps to make sure that we only build those features that you need. So a team, when it's being formed, whether it's for a major feature or whether it's for a service, the first thing they have to do is write the press release. And this is not the official press release that's going out, of course, but this is a press release. In a press release, you often say in very simple but clear terms exactly that what you're going to deliver as a product. Then the second step in that is that they have to write the FAQ. These are basically the 10 or 15 questions that any customer might ask about your product. Step number 3 is that you start to define the user interaction with the product or the service that you're going to build. Step number 4 is that you start building sort of the framework for the user manual. So all of these steps are things that our teams do before even writing a single line of code. The goal of this is to deliver only and exactly only those features that we want to deliver for you and the service. So we structured around that as well. We have this is a pretty well-known term by now, we built what's called two pizza teams. And this is a term that stems from the early days of Amazon, where you would build teams that you could feed with two pizzas. Yeah? Now, if you hire a lot of young graduates from college, you don't get very far with two pizzas. But the goal was to actually have teams that are small enough so that you don't have to hold meetings to actually understand what anybody else in the team is doing. And so you have total control over the development by continuously communicating with each other. So these teams, they're totally autonomous. The RDS team and the Redshift team, although both working in the database area, are totally autonomous, have their own leadership, and run at their own pace. They completely own their roadmap. The roadmap often is being developed in concert with their customers. So the Dynamo team is in continuous contact with their customers to make sure that they can continuously improve their service. And as such, each of those teams also has a different launch schedule. And that's why it often seems that these launches are not very coordinated. They are not. Because important is that we get the functionality into your hands as quickly as possible. This is also sometimes why when we launch these services, we may launch them in 1 or 2 regions first. Because it's more important to get things in your hands quickly so that we can start improving it than to wait until we can launch it everywhere in the world. And so yesterday already Andy talked about that actually the winner this year probably is Redshift, with well over 40 pretty major features added to their product. But I think secondly in that whole list is RDS. The relational database service is clearly also a winner in really improving their service with major features. And so, for example, the whole being able to access your database logs just by point and click is just amazing. It doesn't seem like a major big thing, but for many of our customers that are using RDS, this is super critical and really important. That is one thing on the top of the RDS list that our customers have been asking about. And this is, I've heard the request in the past year and a half so often that it is almost obvious that this is coming. So I'm more than happy to announce that today the major feature is that RDS we're launching RDS for PostgreSQL today. Postgres is an amazing database. It has many features that all of you want, and I know that quite a few of you have been running your own Postgres clusters to be able to actually just get access to that functionality. And I'm more than happy that we finally are able to give you access to this in a fully managed RDS environment. The cool thing is that it immediately gets some of the standard RDS functionality with it. 3 terabyte disks, multi-AZ replication, VPC support, combining that with the stuff that Postgres is really good at, like geospatial indexing, as well as full text search. And so I really hope that with this launch of Postgres for RDS, that we're able to take some pain away, some management pain away from you guys, and that you can actually start enjoying putting those cycles against building better products for your customers. If I look at the way that we do innovation, I like to believe that we set ourselves aside pretty much from the old guard. If you look at the old style technology companies that would deliver platforms, when they would deliver a platform, they would put everything in the kitchen sink in there. And they would launch it as one big bang. And often they would do this a year or 2 years before you could actually really get access to it in production so that anybody can get educated about all the different features that are in there. We inverse that. Our innovation is purely driven by the feedback that you give us. The goal is to deliver features and services in a sort of core functionality first. We are very strong believers in the lean methodology. And lean means that you have to remove waste. And waste, in this case, is anything that doesn't really truly matter for your customers. But also, our customers help us. So there's a lot of feedback that we're getting from our customers, and actually our customers also build great systems on top of us. Build often great open source systems that are truly driving also a lot of innovation within Amazon itself, within AWS itself. And probably there is no other company, no other customer that we have on our platform that is driving so much innovation than Netflix. Netflix, with their open source tools, have helped many of our other customers also helping us to manage AWS much better than what they could do on their own. And I know, especially those on the live stream, there is this Netflix drinking game going out. Yeah? Every time we mention Netflix on stage, you're supposed to take a shot. But, you know, probably you better uncork the bottle of vodka right now, because I'd like to invite on stage Neil Hunt and Adrian Cockcroft of Netflix to talk about some great announcements that they have to make.
Well, good morning. AWS is a great general platform, huge range of applicability, great for building web-scale services, great for a corporate IT initiative, great for a computationally intensive research project. Netflix has chosen to build, get my slide up here. Netflix has chosen to build its streaming entertainment platform on top of AWS. But there's a gap between the generality of AWS and the specific requirements of our business. So we've created the Netflix platform as a generally applicable platform for anyone building web-scale, highly available, cloud-native applications. And we'd like to share the development and the use of that platform with a bunch of like-minded enterprises. So we've open-sourced the Netflix platform. There are 35 projects, like the Simeon Army, like Asgard, some less well-known, but the list will continue to grow as we all figure out what's important and what we can add to this. The energy and the initiative of the community is key to the success of this initiative. Earlier this year, we launched the Netflix Prize. The cash prize is great. We launched the Netflix Prize to spotlight the opportunity to engage and participate in bringing this platform forward as a great platform for building web-scale applications. The cash prize is great. The recognition of your peers is better. But the real prize that everybody shares is contributing to building a great platform that would be better than if we all had to start from scratch. I'd like to introduce Adrian Cockcroft, who's going to announce the results of the Netflix Cloud Prize.
Thanks, Neil. Really, the idea from the Cloud Prize came out of last year's reInvent, and we timed it so that we could come up to this year's reInvent. And the first person I talked to about wanting to do this prize was actually Werner, and it seemed like a good idea to him, and he was willing to be a judge. So these are the 6 judges who chose the winners in the Cloud Prize. Some of them are here, and we just want to thank the judges in particular for taking a lot of time to go look at all of these entries. I'm going to go through the actual entries. We've got 5 at a time here. There are 10 winners. First of all, if you're trying to get used to using Netflix OSS, we have 35 projects. Where do you start? Well, Peter figured out how to get everyone bootstrapped with one click and a whole lot of CloudFormation templates and Ansible builds. He will get you started right at the beginning with almost no effort. Now, we may want to run it in your own data center or in your backpack, as the Eucalyptus guys, the Eucalyptus guys have built backpack-based zones, but they now, from a single Asgard console, can deploy an application into AWS, into your own data center, or even into your backpack. We were looking for how to put everything together, and it turns out IBM were trying to figure out how to do cloud native, and they came to us, and they worked out how to put together all of our tools to build a completely new application that's an example airline booking system called Acme Air. So Andrew put that together. It's an excellent place to start if you want to build your own application. You want to see how these things fit together. Next, the Judge's Choice Award. Joachim comes all the way from Germany, and he put 30 pull requests on a single project. I mean, that is a really dedicated input. And what he wanted was to take our RX Java environments, a sort of next generation programmer development productivity thing for doing reactive development. And he wanted to port it to Scala. So, put all of the things in that we needed to do that. And then there's this language called Pig, and it's kind of ugly to read and there's lots of text in there. So we put lipstick on the Pig. We put a nice user interface on it. And Mark Roddy from Mortar are building a big data platform that needed a user interface. It needed a visualization tool. So they picked up lipstick, modified it, and have been extending it with us. So they've been adding new features to it. Now, when you're working on these projects, you have to worry about doing QA. And we wanted to have a prize entry for quality contributions. So rather than just working on fixing bugs in one project, what Jacob did was integrate the JBoss Arquillian test framework into the base platform that we develop everything from. So now all the projects we build going forward have Arquillian built in. We also wanted to look at performance, and Neil from hotels.com in the UK took our API gateway and benchmarked it and did some performance tuning, ported it to Netty. There's some excellent performance work. Now on the data side, we wanted to look for a contribution there. And what Jackie built is actually a very good example of using simple workflow to integrate the backups sequencing that you want to do from your RDS into S3. And then when we're looking at building highly available systems and routing our customers who are global to all of the Amazon regions around the world, you have to use DNS to send them in the right place. We built a system called Denominator that does that, and Jeff Damick was instrumental in getting that project started very cleanly. He has a huge amount of experience in building DNS APIs, and it was able to really get the project pointed in the right direction. Now finally, you've all heard of the Chaos Monkey. All the Chaos Monkey does is kill machines, and that may be scary enough for some of you. What Justin decided to do is add 14 different ways to torture your machine before it dies. And it's a very scary project, but it's going to really help everything be more resilient going forwards. So we flew all of these people in from Jacob from Poland, people from all over the US, and they're here in the audience. We're giving them all these trophies, which are very geeky from Bleep Labs. They're custom cloud monkeys. They make funny noises. If we get everyone to stand up, and we have one of these for Werner as well. So there we go. Thank you.
Wow, great. I want to emphasize something that I said before they came on stage, is that the combination between the innovative powers of AWS combined with the stuff that you guys do on top of our platform is this epic collaboration. And open source plays an important role in that. Absolutely. It's not just the Netflix OSS, which is really extensive and really helps many customers, but it's also tools like Scala, or databases like MongoDB, or even the partnerships with Eucalyptus. All of these are open source tools that are really important for many of our customers. And actually, if you think about how this startup world, the creation of new businesses has really been powered by cloud, I think we also have to add to that open source. Because I think what many startups do is make use of very high-end enterprise-grade software that is almost available for them at no cost. together with sort of the incremental, the immense power of the cloud, those two things are crucial for new businesses to get started. If you guys were here last year, I did a fireside chat together with Jeff Bezos, the CEO of Amazon, and we talked a lot in that fireside chat about the power of invention, the kind of things that Amazon does and what are sort of the principles behind it. And something that Jeff said there is actually really, really important to our company. Sometimes you think about innovation as doing really big new stuff, new things that nobody ever thought about before. And of course, that can be really important. But what is often much more important is to use your innovations against things that don't change, against things that are forever important to your customers. If you do innovation, for example, in retail, it's easy to see. Yeah, lower prices, a larger catalog, hard guarantees on delivery, faster delivery, and convenience. For each of those dimensions, any innovation we put against those dimensions that don't change will forever benefit our customers. It's like building flywheels. All the energy that you put into it, all your innovative energy, becomes kinetic energy in that flywheel and will stay there forever. So anything that we do, any innovation that we do, has to benefit you forever in those areas. So what are the same things for AWS? It's easy to see how that works for retail, but what are the things in AWS where if we innovate against those dimensions, will benefit you forever? And I believe there's sort of 5 dimensions that are important. Now, first is performance. Anything we can do and give you more tools to actually manage your own performance, but also be able to provide consistent performance everywhere, to improve the consistency of performance. Because if we improve consistency, then it's easy for you to build your applications on. Security is equally important, maybe even the absolute most important priority within AWS. Now, this will trump anything else, but it's important for us when we innovate, on one hand at the operational level, which is something, often things that you don't see, but where we can protect you better and better over time, but also innovating and giving you new tools so that you can protect yourself better. Any energy that goes into that will benefit you, our customers, forever. The same is for reliability. The more tools we give you to actually build better systems, but also the more innovation we do at sort of the physical level, for example, in our data centers, to make sure that we're less susceptible to, for example, power outages or power fluctuations and things like that, will benefit all of you. All the hundreds of thousands of companies running on our platform will immediately benefit from all the innovations we do there. And cost, of course, is something that is important for everyone. Nobody is going to say 10 years from now, I wish AWS was a bit more expensive. So if we can help you drive your costs down with new innovative procedures or new innovative tools, it will help you forever. And of course, scale is important in that world as well. It makes it easier for you to scale. Some of my services hide all the scale from you. They are infinitely scalable from your perspective. So the goal really is to really support today's workloads. And I think we're doing that really well. But most importantly is we also want to power tomorrow's workloads. We want to give you tools and mechanisms such that anything that you can think about, you can start building on our platform. All the new innovation you want to do is really driven by all the tools that we give you. And so let's look at a sort of few of these large workloads. So these are common patterns that you might find back on AWS that you might be using yourself. Whether it's disaster recovery between maybe even your own data center and AWS. You may have web and mobile apps or some high-performance computing, or you may be doing some media distribution using CloudFront. And quite a few of our customers are doing, there's a lot of big data and weblog analysis going on. If you look at all of these different architectures, the crucial point often in there is how you manage your data. Yeah, if you take sort of the computational points out of this, you're often left with left with sort of really key components that are all about how to manage and how to transport your data. So let's take a bit of a look at our data management capabilities from sort of these 5 perspectives that we have. What are the things that we can do under the covers such that you actually can manage your data much better? And important to think there is that you have to take a holistic approach here. Where it is not just a matter of that you can sort of isolate yourself on the front end without thinking about the back end. A good example there is that definitely in the earlier days, when people were running their own databases, for example on AWS, they would have a steady state of requests coming in for their website, and it would hit their database, make all the database changes, and a steady state. But under the covers towards EBS, the traffic was really bursty. So you had to, often customers were wondering why they wouldn't be able to get consistent performance out of their database. Because actually there's this step in between. The database does a lot of work that actually batches all the writes and then has very bursty I/O, not at all related to the steady state input that you have. So to be able to really manage the performance of your database, you have to understand, or even to manage the performance of your overall application, you have to understand each and every one of the components that you're managing and how they are interacting with the subsystems. That's often pretty hard. And we've tried to actually help you get better, consistent performance out of the applications that you're building. So there's a number of observations around this. So let's start with performance. Something that I mentioned last year in my keynote, it is really important to measure anything. You cannot start talking about performance if you're not measuring things. And you have to measure things not just at average, you have to measure things at the end of the distribution. The 99 percentile, 99 percentile, 99.9 percentile, for example, are increasingly important. Because remember, average, the only thing that average tells you is that 50% of your customers are getting a worse experience. So it's really important to measure at the end of the distribution and to be able to control that and push that in. And again, what I said earlier, you have to measure not just only at the output of your system, but at each and the intermediary steps there. And the CTO of Etsy gave great presentation and has some great advice there, that you should put as much data as possible in your log files, including performance information, such that even after the fact, you're able to build a very good picture where the performance of your application is going. And if you talk about storage, I/O is the most important component there. Yeah, it's not about how much you store on disk. If you care about performance, it's all about the I/O. And as I said earlier, the most important thing here is not that you get the highest possible I/O, but that you get consistent performance. Because if your systems give you consistent performance, you can build on top of that. Now, if you look at storage systems, that's increasingly hard. Yeah? These large disks that we're building, whether it's 1 terabyte or 3 terabyte disks, and we're probably not going higher in any density because it's increasingly difficult to get the data off your disks. These large disks are great in consecutive reading and writing. If you want to read a 1 terabyte disk, it probably takes you a few hours if you nicely read block after block. However, if you want to read a disk with random I/O, a 1 terabyte disk, depending on the type of disk and the speed, it takes you somewhere between 15 and 150 days to read that 1 terabyte disk with random I/O. Now, most of our databases, most of our complex applications are not doing nicely sequential reads. They're doing massive random I/O. And especially if you look at sort of the NoSQL systems, the modern databases, they do a lot of very random I/O. And it's hard to get consistent performance out of them. So important is actually that we move towards, if you're really interested in building consistent performance in your systems, to move to flash drives and to move to SSDs as being the core of your system to manage performance. And these things are really good in providing consistent random I/O. And there's a great article written by the guys from Instagram. You can search somewhere on the net that by using the SSD systems, they were able to actually move data 20 times faster between their middle tier and their backend services. And so we've given you these HI1 instances that give you really rock solid 120,000 I/O operations a second. One of the things that you've been asking us for is a lot more variation here. These machines, these instance types, are really important to you. But you want the ones that were actually, maybe could do a little bit less because you didn't need 120K. Or some of you want much bigger beasts. And I'm very proud to announce that we're delivering today to you the next generation of the instance types, the i2 instance, that has an enormous amount of variation and give you great I/O performance. Yeah, so on the lower end side, you'll get lower I/O, but at much lower cost than the HI1s. But if you look at the higher end side of this, the quadruple XLs will give you 175K writes I/Os a second when you use 4K writes and reads. But if you look at the 8XLs, here you're running at 350,000 I/O operations a second. This is a true I/O beast that can serve any of your consistent storage requirements. Let's take a look under the covers, for example, how we do this with DynamoDB. This is on one hand the local disks now that are in the i2 instances. But Dynamo has also this great functionality that allows you to get consistent performance out of the database. You tell us how much performance you want, and under the covers we guarantee you that you get this performance. So this is a typical application making use of Dynamo. Often they're running first at a NoSQL cluster that they're running themselves. So this is an ad serving application. And in the traditional NoSQL clusters, if you run that software yourself, we've got many customers that need to really ramp up their clusters to sort of 30 or 40 nodes just to get consistent performance out of it. Not because you want to replicate it that far, but the reason for replication is purely to get the aggregate I/O out of it that you want. And why? Because under the covers, this app actually does not just make one request to the database for an ad. It actually often does 10 or 15 very small operations asking for what's the inventory, what's the current pricing, what's the profiles, all these kind of different things. And so these many back and forth result in an enormous amount of non-sequential I/O. And so if you use this with DynamoDB, things change dramatically. Because suddenly the performance is guaranteed. If you ask for 200,000 reads or 200,000 writes a second, under the covers, Dynamo will reconfigure itself to make sure it can meet these guarantees. And if you look at sort of the performance of DynamoDB since the beginning of this, since the beginning that we launched it, which was early last year, the average latency of Dynamo is just rock solid, even though they are doing trillions and trillions of operations, but has no effect on the latency that they're doing, that they're providing you with. So it's really important to make use of these tools to get consistent performance out of your database. Yeah, and of course performance is really important for you, especially those that are making use of these NoSQL stores that are making many, many read and write requests against it. So really make use of that. And this is, and of course it also comes at a price. But I think, Valentino of Adwell gave us this great quote that, even though they are doing 100 billion requests against DynamoDB on a daily basis, they spend more on snacks than on DynamoDB. Now, maybe they buy a lot of snacks, but I like to believe that DynamoDB actually, you can really control cost and performance in your architecture there. I'm very happy to announce that Dynamo actually is going to deliver new functionality to you today as well. Happy to announce global secondary indices. Earlier this year we launched local secondary indices, but now you're able to build global secondary indices over any attributes in any of your tables. This will help you tremendously with speeding up any searches that you do over any of the tables that you own. Now, this will replace much of the table scans that you're doing right now. So this is a really important feature for you to manage your performance on secondary indices. And I'm really proud that the Dynamo team has been able to iterate this fast and bring you this very important functionality so fast after that they launched local secondary indices. If we look at our other storage system that's important, of course, for you, is EBS and provisioned IOPS. Yeah? It's really important for you to tell us what you want in terms of performance, such that we can give you the I/O that you need. And so the guarantees we give you with respect to performance on EBS is that if you tell us how much I/O you want, then 99.9% of the time we will deliver this within 10% of the boundary that you give it. You have to imagine that behind the covers there's a lot of things going on to actually make sure that you get this performance exactly right. We'll have spare I/O capacity sitting around there. We'll have making sure that even if disks fail, we still can guarantee you the provision, the IOPS that you have provisioned. And I found that by able to actually make the performance of EBS truly consistent, architectures have become tremendously simplified. Because if you no longer have to jump through hoops with all sorts of caching strategies to get consistent performance, your applications become much simpler. And as such, much more robust. And there's a great story to be told here by one of our customers, and I'd like to invite on stage Ilya Sukhar from Pars to tell you about how provisioned IOPS impacted their system.
Thank you, Werner. I'm really excited to be here. I'm going to tell you folks a little bit about Parse and how AWS has helped us build a really flexible platform that makes mobile developers' lives much, much easier. So, the story of Parse begins in early 2011. My co-founders and I were working on various mobile projects, trying to check out the mobile revolution, and we found that mobile development was really, really painful. It's so messy. Not only do you have to build all the stuff that you had to build in the web age to scale as your usage grows, all these things, but you also have to do it on a bunch of different platforms. Different mobile platforms, different devices, different programming languages, a bunch of repetitive work. So, what does that look like? On the server side, you've got all the things that you expect, everything from physical servers to APIs and security. On the client side, there's a bunch of new challenges. What happens when your users are just in the subway, but they still want to play their game and save their high scores? That has to work, and it has to work on iOS, it has to work on Android, it has to work on Kindle, it has to work on every platform. And then you finally get to your stuff, the code, the part of your app that is actually different from every other app in the App Store. Your users aren't recommending your app based on how well it caches data locally. They're recommending it based on how good the experience is, how fun the game is, what the pixels actually look like. And so my co-founders and I found this really frustrating. So we decided to fix this for mobile developers everywhere. We ditched our apps and we built a platform. So that's what Parse is all about. Make it really dead simple to build great cross-platform mobile apps without focusing on the stuff that everyone has to do over and over again. You get to focus on the parts of your app that actually make you successful in the market, that bring you to the top charts, that actually matter. So let me show you a couple of our products. Parse Data, the very first thing that we built. What we're doing here is we're giving you an SDK that drops into either Xcode for iOS, Eclipse for Android, Visual Studio for Windows Phone, you name it, whatever you're working on, we have it. It drops in and then lets you just in a few lines of code store and retrieve structured data really, really easily. Here's an example, 5 lines of Objective-C. For anyone who's built an iPhone app or done anything on iOS, you probably know that 5 lines of Objective-C doesn't get you anywhere really. You can barely, write your own name to the screen in 5 lines of Objective-C. But these 5 lines of Objective-C create an object, a score, a name, whether a person's cheating or not, and they save in the background. You don't have to set up the server, you don't have to set up the schema, there's no configuration. We'll do the indexing for you. It's really, really just this simple. Push notifications are also a big pain point for mobile developers. They're just expected these days. Everyone's got push notifications. They're a great way to engage with users, to remind them of things, to bring them back to your app. And every platform works very differently. Working with Apple or Google or Amazon, they're different systems. They have different models for notifying your users. But you want to think of your users as users and people, and not in terms of a bucket of devices that they have at home, that they carry in their pockets, wherever they are. So push notifications through parse are really dead simple. We tie them right to your data model. So here's an example. Suppose you're a major sports team and you want to send a push notification to everyone within a mile of your stadium. Well, it's just a few lines of code. Find those people, find the devices that they have, and send them a push notification. It's really, really dead simple. And so we weren't always powering major sports teams. We started small. In the beginning, we had 1 AWS instance. We put together our beta in 3 weeks. We had no clue if this was going to work. We just wanted to, see what happened. We don't want to invest too much. So we started with 1 AWS instance. But over 2.5 years, flexibility and power of AWS has helped us grow tremendously. We've gone from 0 to over 70,000 apps earlier this year. And then we joined Facebook, and our graph started to look a little different. In just 6 months, actually less than 6 months, we doubled, more than doubled, our capacity and the number of apps that we power. These days we power 180,000 different applications. We're doing billions of push notifications, billions of API requests every month. And we're doing this for a really wide variety of apps. So this slide is auto-generated. We do this periodically from the icons of our users. And there's everything from sports teams like I talked about. There's social games, there's big enterprises, there's big brands, there's car companies, all sorts of things. And so an interesting thing about Parse is you can really think about it as 180,000 different databases. They all have a different schema, they all have different scalability requirements, they're all modeling their data differently. There's a lot of variation. And so this is what our infrastructure looked like 2 years ago. Pretty simple. Flexibility of AWS has allowed us to get pretty creative over 2 years. And now we've got a bit more complexity here. We've got all sorts of databases just the sheer breadth of the applications has really changed over time. And certainly the scale has changed over time. We have many, many apps that are charting in the App Store any given day, which really changes what you need to do. The profile of your traffic is different, whether you're in the top 10 or the top 20 or the top 50 across 180,000 apps. That's a lot of variation. We spent a lot of time on scalability because of this problem. These days, we can scale 95% faster than we did when we started out. We can do things that took us hours in just a few minutes. So when that great new social game is really blowing up, we can double our capacity and meet the demands of the app that didn't necessarily ever tell us they were using Parse or didn't even expect to get featured by Apple or whatnot. So it's really, really easy to do this with AWS. Scaling, solved. The flexibility of AWS has also helped us get creative and concoct a real unique combination of database technologies on the back end. We're doing something really interesting with MongoDB. This is where all of our app data is stored. And we actually have over 180,000 collections in MongoDB, 180,000 tables effectively, and actually more because most apps have more than one and most apps have a bunch of indices. So this is a pretty unique use case. And we're doing this at high scale with the help of EBS PyOps. So this is what our graph looked like before latency. This is just our general latency retrieving data from the back end on Mongo. And the baseline latency is okay here, about 200 milliseconds, not great. But you'll notice these spikes. When EBS IO was stalling, we would get write lock contention, and suddenly a user trying to comment on their friend's photo in one of our customers' apps was waiting a while, maybe it was timing out, maybe the app was crashing because they didn't handle that well. Hard to deal with. After we turned on apps, things got a lot better. Our baseline latency dropped in half. Our spikes went away. So now those photo comments or those games are doing just great. And in general, we've been able to scale faster because it takes us over 80% less time to bring up a brand new machine, which means we can deal with these spikes in traffic when we need to with fewer warm-up steps. So our business really wouldn't be possible without AWS. We started with one instance and we kept going and changing and just building what our developers wanted, and we never needed to stop and rethink who we were using for infrastructure. And I really realized this on one particular instance, so I'll leave you with a customer story. Our very first big name, recognizable customer that you guys might have heard of was the Food Network. And the first time I got in touch with them was actually after they had built, tested, deployed, and actually advertised their app on national TV. They were calling me and asking like, hey, where do we send the money? Like, how much do we owe you? And I was really happy to have that conversation because I was thinking about my business and how I could make it work for myself and for them, and thinking about the important parts of what differentiates us. And I wasn't, worried in the back of my head, did we scale? Did we stay up while they were on national TV? I just took care of what really mattered for me. And so that's what AWS did for us, and that's what AWS can do for you. Lets you focus on the important differentiating parts of your business. So thank you, and I'll hand it over back to Werner.
Great story. And not only that, I think they are a great example about how when you move to consistent performance, your application becomes, or your system becomes a lot simpler. The pre-warming that they needed to do of their databases no longer was necessary because they knew they were getting consistent performance out of their storage system. Now let's look at sort of the next point in the list of things that if we innovate against it, they will benefit you forever. And I think each year we launch a number of great features to help you better protect yourself. The fact that VPC is now default helps you tremendously by being explicit. You have to open up things instead of that you have to start protecting them. Everything is locked down by default. You have to open them up. You have to make conscious decisions how and what your data can be accessed. So I think the important fact here is that we can give you very fine-grained control over your resources to really determine who has access to what data or to what service, in what role, under what conditions. IAM roles, so identity and access management, are going to become only more important. The fact that you're able now to determine really who has access, who can start which virtual machine, when they're in which role. Are they able to start a dev and test machine, but they're not allowed to touch the production machines? All of these are extremely important. And this fine-grained access control is very simple. For example, in S3, that makes really clear who has access to which objects, to which buckets, what operations they can do on those objects. But how do we do this in databases? And many of our customers who actually want to directly access the database or have their customers access data in a database often had to build proxy servers that actually would take the request, would validate the request, see who the customer is, and then determine which data within the database will be accessible. And I think something that was extremely powerful and announced last month was the fine-grained access control for DynamoDB, where you can determine which of your customers, in what role, are able to access which rows and which fields in the database directly. That greatly removes a whole piece of architecture that our customers had to build before. And especially those that were building mobile applications. they can now access DynamoDB directly from their applications without having to build proxy servers to isolate customers from each other. We give you those tools. And I think it's not new because it was launched earlier this week, but this is really key for many of you as well. This doesn't seem very sexy, but it is really important for many of our customers to be able to use very different single sign-on systems and then be able to actually merge that with your IAM and your IAM roles. But it's not just access control that is important. Encryption will play an increasingly important role for many of our customers. And we will, as I mentioned this also last year, I really expect that in a number of years, encryption of your data, both in transit and at rest, will be default. You will have to decide not to encrypt things. And we see that already with HTTPS. I mean, 5 years ago, we had this discussion whether HTTPS was too expensive. Yeah, over HTTP. Today, there is no consumer service out there on the internet that is not making use of HTTPS. So that discussion we've had. The same will go for encryption. And not only to meet sort of the compliance and regulatory requirements, but purely because you want to be in control exactly who has access to your data. And so let's look at, for example, how we do this in one of our services. So this is sort of a diagram of Redshift under the covers. Now we make use of two different VPCs there. One VPC is under your control, which holds often your BI tools that can work, so that the standard BI tools all work together with Redshift seamlessly. You can put them in one VPC, and what's also in there is the master leader node of Redshift, of your cluster. But behind the covers, the worker nodes are sitting in a separate VPC. There's clearly controlled to make sure that there's no other access possible to those nodes than from the leader node. And also what we do by default in Redshift is encrypt your data. And so each data block in Redshift is encrypted with a random generated block key. Then those block keys that you have are merged together, put together in a package. And then they are encrypted with the cluster key that is only available in memory at the cluster. And you can store that, for example, that block somewhere in, or the block of keys in S3. But this was the case where we would actually control the master cluster key, the cluster key. What we offer you now, as launched earlier in this week, is integration between Cloud HSM, which is the hardware security module that you have, that you can get in the cloud, but many of our customers also have them on premise, where you can actually store your keys in and be assured that the service provider like us does not have access to your keys. So we integrate the Cloud HSM with the encryption tools in Redshift to make sure that you can encrypt the database keys with your master key, such that without access to your master key, nobody has access to any of the information stored in your cluster. This is a really important functionality for our customers that want to be assured that no one has access to their data, except if they have access to, if they can use the Cloud HSM device. And Cloud HSM, in my eyes, I always call this a sort of a James Bond device. Yeah? You can store your keys in there, but if anybody touches the device, these keys automatically get destructed. And this is really important. It means that none of the workers at your service provider have ever access to your keys. Yet you can do cryptographic operations with your keys to make sure that only you have access to that data. Reliability is, of course, something that is always on our mind. Now, many of you are already making use of many of the tools that we have, and I like to emphasize this once more. Use multiple availability zones. There is a reason why we built these things. It's not just for scale. It is just that you can build reliable applications. Please make use of that functionality to ensure that your applications can be available under all circumstances. Actually, a pattern that we see much more arriving these days is beyond the availability zones. Many of our customers are actually using multiple regions to ensure disaster recovery or disaster management. And one area where that actually showed up pretty early on, you know, with the 3/11 earthquake in Japan, the disastrous earthquake there, what we saw with many of our Japanese customers, they came to us because often they already had only one data center and wanted to make use of our multiple availability zones to build a really highly available business. But what they also would do is actually back up all of that data into Singapore, into the Singapore region, to make sure that if there ever would be an extended disaster that would render, for example, the Tokyo region inaccessible or unusable, that they could restart their business from Singapore. And for them, this was a really realistic failure scenario. Something actually the whole sort of natural disaster world, I've heard, have quite a bit of impact in how customers are thinking about geographic replication or geographic disaster recovery. The CTO of Druva, who are an enterprise backup company, told me that in the wake of Hurricane Sandy here in the US, he got enormous interest from companies in the northeast of the US in helping them do geographic backup into other regions in the US to ensure that their business could survive any sustainable outage in their own data centers. We've been helping you, I think, in the past year with making it easier to do cross-region operations. Yeah, we've had AMI copies, EBS snapshots, RDS can do snapshots. We give you the tools with Dynamo to copy databases over to other regions as well. And I'm happy today to announce that the Redshift family is actually joining this as well, with being able to do snapshot copy across regions for Redshift as well, to make sure that your data warehouse can survive any form of regional failure. I'm also very happy to announce today very important functionality to even make it easier for you to do cross-region reliability. Amazon RDS supports cross-region read replicas starting, I think, later this month. Yeah? This allows you to build a whole range of different failure scenarios. And if you look at sort of disaster recovery, which is all about sort of minimizing the risk. Yeah, some of you are all depending on how long you're willing to sustain an outage. So what is the cost of a service interruption for you? Yeah, if you do just backup and restore, yeah, you may have to, you just move your snapshots to the other region and they're able to actually restart from that region. Quite a few of our customers are using sort of a pilot light functionality, yeah, where you will have one server sitting there that sort of keeps a light on that receives the data, now probably using read replicas from RDS, and you're able to restart your applications there, making use of a CloudFormation script. Another scenario that is being built and can make use of sort of the read replica replication that we have right now is able to actually have sort of a warm standby, where there's more complexity in your application, where there's often caches, where there may be other things that need to be pre-warmed before you can start your application. And so moving the data over there and having it in standby mode, where then Route 53 can automatically move all the traffic over to the other region, where your application sits there completely pre-warmed. And of course, there's quite a few of our customers that are really interested in building these very extensive architectures. Yeah? Netflix being one, so take a drink now, guys. Yeah? Netflix is one of those that is actually making use of multiple regions to send live traffic to each and every one of those regions. And we see more of our customers interested in building architectures that can actually make use of this. Where, for example, they will send localized traffic to the region that is closest to them, making use of Route 53, and where customers automatically get connected to the closest region that there are, that's close to them. All of this is all about how do you minimize the risk for your company. And there's a trade-off there. There's a trade-off between cost and speed of disaster recovery. And so we give you many of these tools to actually manage your cost. There. And if you look at storage systems again, there's sort of always a trade-off between sort of the different things we have can give you in terms of storage functionality, and the differences in I/O performance that you can get out of them. For example, if you just look at key value, we'll give you DynamoDB, which has rock-solid single-digit latencies, and then you can drop into S3, which is also a key value store. You can drop into S3 with reduced redundancy. That gives you still the key value store functionality, but not the 11 nines durability that standard S3 gives you. And then you could even drop into Glacier if you're willing to trade off access times for cost. And so what I more and more see in architectures happening is that customers are really aware of sort of the cost of storage, and cost of I/O. They will store hot data of their application in DynamoDB because that's where they need very fast and consistent access to. And then they will start moving data that is colder into S3, where the service then that sits in front of their application determines whether it should go to Dynamo or whether it should go to S3 to read the data. And here they can have clear trade-offs between performance and cost and reliability. But of course, if we talk about cost, we also have to talk a bit about compute. There's no way getting away from that. And Andy already talked about this yesterday as well, how important the spot market is for many of our customers, for you to help you completely control the cost. And in my eyes, the spot market is so unique. As IT professionals, before this, we never had the chance to determine for ourselves how much we were willing to pay for something. It is always the service provider that determined how much you should pay for a particular operation. Now, you can start to determine how much is it worth to me to have this report generated on Monday afternoon instead of Friday. If you're willing to actually relax the timescales over which you need to do your operation, you have much greater control over your cost as well. So on one hand, this is how we thought about. Definitely in the beginning, it was really well suited for sort of batch-style operations that were not time critical, or for those who actually wanted to do a lot more work, a bit like overclocking your CPU, where you get much more performance out of it at the same price point. And many of our customers are doing really great stuff with that. Hungama is a very big Bollywood streaming company across the world. They make use of the spot market for transcoding. So what they do is they build a queue, dump all the transcoding work in there, and then bid very low on the spot market. And whenever EC2 instances become available for them, they will start transcoding. But much of the transcoding they do, they really make sure that they checkpoint along the way. So even if the instance is taken away from them, the work that they've done during that half hour or 45 minutes has not been lost. And it's a very easy application there. Last year, we had Pinterest here on stage talking about how they manage costs in their infrastructure, and they actually make use of the spot market to allocate front-end instances. They were able to actually drop the cost of their front-end operation, which is something like 150, I think, or 175 high-end Python web servers. They were able to drop that cost down to something like 25% of the original cost by making use of the spot market. And I very much like the things that the Vimeo guys have done in their usage of spot. So Vimeo has two different business models. On one hand, you can have a free account with them, and there's also a professional account. And I don't know if you make use of Vimeo, if you upload a video, if you're in the free bucket, it might take a while before the video gets transcoded. If you're in the professional world, your video gets transcoded immediately. So how do they do this under the covers? To manage their free accounts, is they do the transcoding of their free accounts on the spot market. and they do the transcoding for their professional accounts, people who pay, in an on-demand instance. And so here they're able to actually make sure that their free accounts are able to have still excellent access, but at a really reasonable cost level. In exchange for that, it takes a bit longer to actually get the video transcoded. And this weekend, there was a major announcement from one of our partners as well. Cycle Compute is a really innovative powerhouse that is able to make use of all of the compute capacity that AWS can offer to solve real-world problems. And this weekend, Cycle Compute launched a major computational exercise where they allocated well over 16,000 instances on the spot market in 8 regions worldwide. And this was well over 150,000 cores they were running for a number of hours. And this is sort of well over hundreds of years of computation just done in a number of hours. And this was a computation that was actually looking for organic compounds to build better solar systems. It's amazing computations that these guys do, very wide, and all on the spot market. So if their customer would have had to do this on-premise, the estimation was that it would cost them $68 million to get the hardware in place to do this. And as you can see, this whole computation, this 150,000 core computation, only costed them $33,000 on the spot market. It's amazing innovation that these guys do. And many of our customers ask us, how should I use the spot market? How should I bid? One of the advices we always give our customers is to think about, what is sort of the cost of interruption. What I mentioned earlier on, for example, with the Hungama ones, these guys are really smart because they checkpoint the state of their transcoding to be able to restart it. But many of our customers, you think about these mission-critical applications on the spot market, checkpointing and restart is a very important tool for you to actually drive the cost of interruption down. Now we've talked a lot about sort of what is sort of the things around data and I/O and consistent performance, and we had this very nice new instance types that give you a whole variety of control over your I/O. But what have we been doing for computation? We launched earlier this week, or last week I actually believe, our G2 instance. This is a new cluster compute instance that has one new NVIDIA board in it, the Kepler board, which has about 1,500 cores on it. It's different from the CG1 that we have. This doesn't replace the CG1. It's not a faster one of the CG1. It is just one with a sort of different style of GPU programming. The CG1s actually have double point floating point arithmetic, which makes them really well suitable for general purpose GPU programming. And these ones are much better suited for any type of media conversion and media streaming. Yeah, actually, they also have hardware accelerated video encoding, but there's abilities to actually grab the frame buffer and then encode that and operate on that. And these G2 instances are actually the basis for Amazon AppStream that Andy announced yesterday. But it's not just on the GPU side that we've made innovations. No, we also are adding a new instance type to our family that is the absolute highest performance processor instance that we have. Happy to announce the new CG instance type that has a Xeon Alpha Bridge processor in it and a whole range of innovations around improving network performance. Yeah, so the inter-instance latencies have been brought much down, much lower network jitter, and it allows you to run sort of the highest performance HPC applications that you can find. I remember when we launched the CC2 instance that we actually ran an impact and figured out that we were sort of 42nd on the list of supercomputers out there. We also ran an impact on this one, but we didn't really make it a real strict effort. But if you throw a bunch of these together, you easily get a supercomputer that fits into the top 25 of the supercomputers in this world. But you get it on a per hour basis, on a pay-as-you-go basis, and you do not need to invest hundreds of millions of dollars to get this in your own data center. So again, there's a number of variations in here with respect to how many CPUs you get and how much computational power you get out of these computational beasts. So the last one on this list was actually scale. What are the kind of things that we do? And many of our customers are doing amazing things on our platform in terms of scaling up. We really help many of our customers grow way beyond their wildest dreams. And so one of our customers there is a small company in the Netherlands called WeTransfer. I don't know if you've ever used them. This is a company that allows you to send large files that are too big for email, but then send it to customers and take them and have them download it. So these guys easily do 4 petabytes of data streaming out of S3 on a monthly basis. And their business model is that they help artists to actually get access to larger audiences as well, because behind their application are beautiful wallpapers. And they serve well over 230 million wallpapers a month. And if you see how they're growing, in a whole month last year, the kind of transfers that they were doing is the number of transfers that they're now doing in 1 week. And they never have to think about it. They never have to think about just that, as Ilya said earlier, they no longer have to think about scaling. It just happens automatically for you under the covers. These guys have transferred well over 650 million transfers since they got into business. And in this month, or last month, in October, they did 46 million transfers. And they acquire about 1 million new users every month. This is a great, simple application that could only live by the power of the cloud. I'd like to introduce to you one of our great customers that really have built their business totally on top of AWS and know all about scaling. I'd like to introduce to you Mike Curtis, the VP of Engineering of Airbnb.
Good morning. So excited for the opportunity to talk to you today about what we're up to at Airbnb. Airbnb is reinventing travel. What we've created is a community-driven marketplace that brings together hosts and guests from around the world to create local, unique, personal travel experiences. And all of that stuff starts with our hosts. Around the world today, we have more than 350,000 people who are hosting guests on Airbnb. These are normal folks, just like us, who have an extra room available in their house, or maybe a time that they're not using their house. And what we do is we make it possible for them to make that space available for rent on Airbnb. And then what we do is we connect our hosts with guests who are looking for a different kind of travel experience. They're looking to stay with a local and experience a neighborhood the way a local does. So this is great for the hosts because they get to earn a little extra money off their unused space, but it's great for the guests as well because they get an amazing travel experience. But that's not even the best part. Airbnb is also great for the cities in which we operate. I want to zoom in for 1 second on New York City, where we recently did an economic impact study. Here's what we found. In New York City, 60 to 70% of all the hotel rooms in New York City are concentrated in Midtown Manhattan. So what does that mean? It means if somebody's coming in to travel to New York around the world, in a lot of cases that means that they're just traveling to Midtown Manhattan. That's what New York is to them. But if you look at Airbnb, you see that 82% of our listings are outside of the Midtown Manhattan area. So what happens? Guests travel to an Airbnb. They stay with a local. They experience New York like New Yorkers do, and then they turn around and spend money on local business. We found that in the last 12 months, Airbnb has generated more than $500 million in economic activity in New York City alone. So this idea of sharing and traveling in a new way is really starting to catch on. But for a second, I want to just take you back to 2009, when things were just getting started. What this shows is density of listings by city on Airbnb in 2009. And you can see back then, we only have one city with more than 1,000 listings. That was New York. You fast forward to 2010, you see we're starting to catch on in Europe, Berlin, LA, San Francisco. 2011, things really start getting global. We're in Australia, South America, all over Europe. So why does it grow so quickly? Airbnb is a marketplace, but we also have an incredible network effect. And think about it. A guest from Australia goes and travels to New York, stays with a host, has an amazing experience. They go back to Australia and they say, hey, I've actually got an extra unused bedroom in my place. Maybe I'll become a host as well. And for that reason, we grew all around the globe very, very quickly. Looking at 2012, you can see that it has become a global phenomenon, what we're doing at Airbnb. Today, we're operating in 192 countries and over 22,000 cities. Looking at our growth of users, you could see it actually took a little bit of time to catch on. It actually took us 4 years to get to our first 4 million guests on Airbnb. You think it's like a supply and demand problem, right? Like you have to have enough supply to get the demand and vice versa. So we really had to build it up. But once the engine started running, it started going very fast. Since the beginning of this year, we've added 5 million more users to that number for a total of 9 million people who have stayed on Airbnb, and this is showing no signs of slowing down anytime soon. On any given night, 150,000 people are hosted on Airbnbs around the world. So, all of that growth, I'm sure you can imagine that we've had to deal with some infrastructure scaling problems. And that's where AWS comes in. AWS has been our platform from day one. Literally, the first servers that ran Airbnb.com were EC2 instances back in the day. Today, we use a wide range of AWS technologies. EC2 and S3, of course. We were also one of the early customers of RDS, Elasticache, Route 53, Redshift, which isn't even up there. Pretty much anytime we can use an AWS service to solve a problem, we will, so that we don't have to solve that problem ourselves. I mentioned we were one of the first customers of RDS. Today, we have over 2 billion rows stored in RDS. Looking at EC2, back in 2010, we only had 24 EC2 instances back then. Today, that's up over 1,000 and growing all the time. Photos are extremely important to us. High-quality photos of a listing can be the difference between it ever getting a booking or not. Back in 2010, we had about 300 gigabytes of photos, about the same as my iPhoto library. Today, we're up at 50 terabytes and growing all the time. S3 has made this really seamless for us to scale. So why AWS? Well, I'm hoping that what I show you next will make it clear. All of this growth, all of this scale, and we do it with a 5-person operations team. What AWS makes possible for us is to concentrate the vast majority of our engineering resources, of our time, of our mind share on the problem of reinventing travel. AWS handles scaling our infrastructure. We really believe that one day, Airbnb could make it possible for people to feel like they're at home anywhere they travel in the world. And AWS is going to be a partner that helps us get there. Thank you very much.
It's really cool because I'm a big customer. There's many places where I go in the world where I will no longer use a hotel room, but actually make use of Airbnb to find a place that is much more interesting to actually stay at than in something which is just cookie cutter. Also, the numbers that these guys have are just amazing. I'm very proud to be able to power such innovation and such disruptive industries everywhere. Many of our younger businesses, definitely, but also larger organizations, will tell you how important scale is to them. But I hope that we have given you a bit of idea of all the innovations that we do under the covers to actually for these sort of 5 dimensions, that if we do our best in each of those 5 dimensions, any effort we put in there will benefit you as our customers forever. Now, at the end of this presentation, I want to kind of shift gears a little bit and talk about some stuff that I'm actually really excited about, some new things that are happening on our platform that is just mind-blowing at times. Now here, you see a number of our customers. So what have all of these customers in common? You know, what does a thermostat have in common with the Mars rover? What do phones and oil platforms for Shell and what do gas turbines of GE have in common with AWS? Or with each other and with AWS? All of these things that you see here are connected to AWS in some way. And it's extremely exciting to see all the innovation that our customers are doing to sort of connect the physical offline world with the computation and storage power of AWS. You know, the Nest thermostat is backed by AWS. The Mars rover streams all of its data onto Amazon S3 so that researchers can collaborate there. The Illumina guys that have this sequencer store their data directly in S3, where then they give tools to their customers to analyze the sequencing data. Tata Motors is instrumenting their trucks with all sorts of sensor data that can then flow back and actually make sure that they can do predictive maintenance, preventive maintenance, and things like that. We're collaborating with GE on their industrial cloud, where they instrument their gas turbines with many different sensors. All of that data flows onto AWS, where it's then being analyzed to give information back to the owners of these gas turbines in terms of efficiency, in terms of, again, maintenance and things like that. A lot of very exciting things. And of course, we as individuals carrying our cell phones are becoming sensors as well. The many sensors that there are in our cell phones are made for very interesting devices. For example, a very simple one, but an interesting one is a young company called Human, who have built an app for your iPhones, where they measure your activity just to motivate you to be active for 30 minutes a day. And what happens is that they take all of that data that they collect from your phone and then move that onto AWS, do analytics there, and get a sense of whether you were actually moving or whether, and what kind of activities you were doing. Really cool stuff happening in sort of combining the offline world with the online world. And I don't know if you see me walking around, if you took a close-up of this one. There's an interesting young company in Sweden. They're called Narrative. And this is what is called a live logging application. Yeah? This little device here will take a picture every 30 seconds. And so anything that you encounter on a daily basis is actually getting recorded. And then all of that data is moved onto AWS. What you see here, the images behind there, is when I arrived here on Monday at Las Vegas. You see me go to the airport, okay, take a card over to here. You see me working together with Matt on the Keynote. And somewhere at the bottom there, there's the public house where we were drinking as well. Yeah, and so here you have sort of an image of your whole day. You can make great time-lapse videos out of that. Again, combining the offline world which all becomes data-generating sensors and move that data onto AWS. And there's many, many new, really innovative products being built. I'd like to invite Greg Duffy, the CEO and co-founder of Dropcam on stage, to tell about how they build their application on top of AWS.
Good morning. We founded Dropcam to answer a really simple question. What goes on at home when I'm not there? It actually all started out with kind of a funny story. My dad was trying to figure out which neighbor's dog was regularly, shall we say, fertilizing his lawn. And he decided to buy some IP cameras to try to figure out if he could capture a video of whoever the culprit was. And that's where the problem started. My dad is actually an engineer, like many of us. And even he had problems setting up the IP cameras. You had to know how to set up port forwarding on your router, what IP addresses are, all kinds of technical mumbo jumbo that an average user just doesn't have time to deal with. And that's not where the problem started. He eventually got them set up. It took him weeks to get them running. And then I remember the first time that he almost caught the person. He came home, he saw the evidence in the yard. He rushes into his computer and realizes that the computer hasn't been recording for a couple of weeks because Windows rebooted to install updates. So it's kind of like a sitcom moment for him, just never being able to capture the dog that's actually doing it. So what we quickly figured out is that if we were going to build a solution to let you know what's going on at home when you're away, we couldn't just build a camera. We had to build a cloud video service that abstracted away all of those problems and let you just focus on getting the video of the things that you care about. So that's what we built. Today, Dropcam is both a Wi-Fi monitoring camera and a cloud service for your home so that you can view it from any of your devices anywhere in the world. And we also record to the cloud so that you don't have to worry about PC running Windows like my dad did. And one of the things that we didn't anticipate because we built this cloud service is that we became the largest inbound video service on the entire internet, which is pretty crazy. So I'm going to give you a little bit of data about what that actually means. There's more video uploaded per minute to Dropcam than to YouTube by orders of magnitude. There's petabytes of data coming in every month. And there are billions of motion events that have actually been detected over the lifetime, and we're now getting to billions every year. So we moved to AWS, we're taking in all of this data, so I feel like this is a good moment to thank Werner and the AWS team for that amazing free inbound bandwidth that we enjoy on EC2. Yeah, let's get a round of applause for that. I assure you it was only a coincidence that we moved to AWS right after that pricing was announced. But actually, we did move right at the point where we hit this amazing scale curve that we're seeing here, which is the amount of video stored in Dropcam. So I'd like to take you through a little whirlwind tour of what the platform that enables this huge ingress of video to be scalable in the cloud, what that looks like. So it all starts with the camera. And at the camera level, we're actually taking about 1 gigabit per second of raw video data and compressing it all inside the camera down to 200 kilobits per second. This is critical to fit it over your home's broadband connection because upstream bandwidth is just there's not that much of it in the average home. And it's over 1,000x compression ratio that we're doing there. We encrypt all of that video, we send it up to a system called Nexus, which runs on EC2. Nexus is developed by us internally in Scala, which is a really cool language that runs on the JVM. And Nexus does 2 things. One, it can instantly mirror the video to your viewing device in real time, so all those platforms that I mentioned before, and get it into the correct format so that you can view it there. Number 2, about 40% of all cameras on the Dropcam ecosystem are on cloud video recording, which is an amazing number. So it actually takes that data, all that video data, and stores it in a custom data structure that we developed to sit on top of DynamoDB and S3. We also have a pretty standard web platform that's Python on Postgres. We use all the standard CloudFront, Route 53, all the tools there. It's nice to be able to just kind of have with all the other technical problems that we deal with, run a pretty standard web platform on top of AWS. I'd like to tell you about another really cool thing that we do, going back to Werner's point about connecting hardware to the cloud. So it's really cool. We not only take in lots of video data, but we take in lots of metadata coming from the cameras as well. For instance, Wi-Fi signal strength. So any part of the Dropcam ecosystem can send data to this platform called the Dropcam Analytics platform, which crunches all that data with EMR and puts it into an online database so we can query it with our admin tools. That's about 300 million data points added every single day. So that's a lot of data as well. But the cool thing that we can do is for things like Wi-Fi, which is usually a black art determining whether one driver is better than another, we can actually A/B test Wi-Fi drivers. And this is a whole new thing. We're familiar with A/B testing from the web world, but now we can bring that to hardware, deliver better Wi-Fi performance in your home by using data to solve that problem. So I think that's really cool. A more user-facing feature of sending lots of data up to the cloud is this new feature that we just launched into beta called activity recognition. Activity recognition is the first computer vision algorithm to be launched at this scale. It actually tries to automatically categorize the motion events that happen on your camera, and so you can ignore and subscribe to just the things that you care about, which is really cool. And we just launched it into beta. We're already processing about 8 million activities every day, and that's years of video cumulatively going through the system and running through pretty complex computer vision algorithms. So I'd like to end with a little video to show you some of the things that people have captured with DropCam, and I think we're going to cue that up here. So in the top left here, we have a family that sent us a video clip of this ninja dad moment. You develop ninja reflexes when you become a dad. That's just a known thing. And they caught this on video with their DropCam and sent it to us to brag about it. and I thought that was really cool. In the top right, it's kind of crazy. DropCam was the only camera recording a collapse of a bridge in the I-5. And it was the only video evidence of what happened. In the bottom left, we have a burglar that got caught in real time by a user. They sent the police in, caught the burglar on camera, and actually got all their stuff back. And in the bottom right, we have Frankie the tortoise, who streams live from his back using a DropCam with a battery pack for 8 hours a day from Lou's Pet Shop. Don't worry, PETA, it's a humane harness. The DropCam weighs less than a pound, and he weighs about 50. So those are just some of the things that people have captured. That's the power of the cloud video monitoring with DropCam on Amazon Web Services. You can buy DropCam at Amazon.com as well, and you can also go to dropcam.com to learn about this stuff and come help us work on it. So thanks a lot, Werner, for inviting us, and thanks for listening.
Nobody of you ever saw that turtle, eh? No. It's just the 180 other million people. Yeah, it's just. So there's many other very interesting things happening on our platform in terms of what you often call the Internet of Things, but I find that a bit of a vague term for me. It's really connecting sort of the offline world with the online world. And there's great stuff that our customers are doing. I don't know if you guys know about the One Bus Away platform. It's been developed on by the University of Washington, and it's an open source platform where every public transport provider can make use of for themselves. What it does is you have actually put GPSs on buses and have some communication technology available there, and then anybody standing at any bus stop can in real time see which buses are coming and how far they are away. And that's when sort of the companies themselves are integrating it into their buses. But we also see where cell phones are becoming the sensors instead of the GPSs, because each of those carry a GPS as well. MoveIt is a young business out of Israel that's making use of your cell phone technology to also indicate how far are buses away, how congested are they, and they give you real-time traffic information. If you want to go from place A to place B, they may give you a different route based on how busy it is in a bus or how congested the roads are. Very interesting technologies there. And another one that I recently encountered that's a very interesting one. It's a company called Deconstruction. Apparently, in the construction industry, it's really important to measure all sorts of environmental conditions. Many of them have legal implications. For example, the noise around a construction site. But also, for example, you need to measure humidity and temperature before you can actually decide to pour a concrete floor. And often again, these have sort of legal implications. If a contractor poured it when it was too hot or too humid, you may have very important implications of that. So these guys have built these sensors that you can place anywhere in your construction site. Yeah, often they are pervasive throughout the construction site, measure all the environmental conditions. All the data get automatically streamed onto AWS, where it's being analyzed and in real time presented to those who are managing the construction site. Much of our customers here actually have some challenges. Yeah, how to collect these large amounts of information and data in a reliable fashion without losing any data. And then in real time, being able to processing that. You know, it's actually an application where we have a lot of challenges with ourselves. We had to solve for ourselves as well. Imagine all of the capacity that you guys are using, all of the virtual machines, all the storage, all the databases, the queues, workflows, all of these things that you're doing. We need to measure everything because we need to bill you for it. And we need to do this in a highly reliable fashion. We cannot lose any of those events. So here we have streams of data, easily tens of gigabits of data that actually need to flow into systems to be able to be processed in real time because you want to know in real time about your users. And it's not just us. Now Adrian was on stage early on, has made this comment once that, you know, Netflix is actually a log-generating application that just happens to stream movies. And some of our biggest challenges are under the covers to make sure that we can process data in a very reliable and real-time fashion. And so it's much more important that we see this shift happening from, you know, not many more being that much interested in terms of big data of what was happening yesterday, but much more important, what is happening right now. Yeah? What are the topics that are trending? Yeah? What is the click-through rates right now? How can we respond right now? How can we give real-time recommendations right now? And so we have all of these different applications, all of these different customers that actually need to process data in real time. And so it's hard, actually, you know, taking in all of that data in a reliable fashion and then processing it in a timely manner. So that the Hadoop cluster world is great for analytics or for actually processing large amounts of data, but it's definitely not suitable for doing real-time operations. On the other hand, you know, with all these distributed messaging systems that are focusing on these kind of, you know, processing frameworks, but I think their biggest challenge is actually on one hand to configure them, but also they're not that great in super reliable ingestion of data. And if you look at one of our customers, for example, Echo, they have a real-time streaming product where they take lots of information, lots of news items in, and then process those, and then actually serve them to many large customers like CNN and Coke and you know, Washington Post, and all of these in real time to be served to their customers again. And so they easily do, you know, on average about 1,000 items a second that they take in, but they have easily bursts that go like 13,000 a second. They actually sometimes do well over 20 million, you know, ingestion of items on an hourly basis. And then again, they do the processing in a timely manner and then outputting this. And these guys have built really amazing technologies, but we need to make this easier for anyone that needs to do real-time operations. And we talked earlier on, remember that we talked about the flywheel, the kinetic energy. This is a great word. It comes from Greek and it means, kinesis means that, you know, a movement or activity in response to a stimulus. And I'm extremely excited to announce a brand new developer-oriented AWS service called Amazon Kinesis that helps you process data in real time at any scale. So what does this mean? Yeah, it means that, you know, you can provision reliable input streams that automatically replicate to 3 different availability zones, and where you then in real time can process the data that comes out of those streams. So let's take a look. Let's take a little bit of a closer look at this. Yeah, so this is sort of the normal steps that you would do. You provision the throughput that this system requires. And you can take any data, any amount of data in, based in sort of steps of 1 megabits a second. Megabyte a second, sorry. And up to 1,000 transactions per provisioned capacity. and you can add and remove capacity dynamically. Under the covers, you can take all of this data and it gets automatically replicated for you in a consistent manner, and you will not lose any data. And then on top of that, you can provide, we will trigger for you auto-scaling in your applications to make sure that you can process them in a timely manner. Yeah, so a simple picture here is this. You build a Kinesis stream, you put data into that, and your application will read from this stream, and it will get triggered automatically. You can add more streams if this is what you want. You can automatically scale this up by actually adding more capacity, asking us to add more capacity to your streams to make sure you can handle all that data. And you can auto-scale the applications behind it on metrics that you provide. Which means that to guarantee the timely processing, you can auto-scale this group to make sure that the data is processed in exactly the time that you need it to be processed in. So this helps you to build different real-time applications. And actually, it's not just one type of data that can flow in there. You can have multiple different data types flowing into your Kinesis streams. And then we'll route this to the applications that will need to handle the particular data for that particular data type. And we built from the start integration with many other systems. So there's automatic integrators into Amazon services such as DynamoDB and Redshift and EMR and RDS. But there is also a standard connector to Storm, which is a very popular open source processing framework. So you can make use of Kinesis to reliably ingest data at any scale, at any speed, automatically process this in real time, and then feed it into processing frameworks such as Storm. Now, I think this is a really cool, amazing new service where we can build tremendous innovative real-time applications with. And I've announced quite a few things today, and I wish I could have demoed every of these other applications or every of the other new announcements that we made. But I decided that it was more important that we would give you a demo of this application. So I'd like to invite on stage Kwaja to give us a demo of Kinesis.
Thank you. We've had the opportunity to, one second, can we bring up the demo? We've heard a lot about the opportunity of working with data today, and so I'm very pleased to be able to give you a brief data of Kinesis, a new real-time, fully managed streaming data service. Social networks have become an incredible source of data, so let's see what we can do with an Amazon Kinesis and a stream of data from Twitter. We put each tweet into a Kinesis stream, which immediately persists the data across the multiple data centers and makes it available for your streaming apps. Let's turn on a Kinesis app that streams the data into DynamoDB for real-time analytics. As the tweets are streaming in, we measure the popularity of each word and create a tag cloud in real time. DynamoDB enables your apps to aggregate high throughput counters with a few lines of code and zero middleware. This tag cloud is evolving in real time, but let's see if we can narrow in on some words that you and I may care a little more about. Personally, I'm more excited about space exploration. What can the Twitter sphere tell us about the popularity of various planets in our solar system? Turns out that Mars, my favorite planet, is actually very popular. So let's find out what's driving the popularity of Mars on Twitter right now by consulting a powerful data warehouse. We will turn on another Kinesis app that uploads the data into Redshift for analysis of historical trends. Now, warehouses are optimized for bulk data inserts, but Kinesis actually makes this easy as well. It buffers the data into a highly durable storage system with checkpoints to reliably and efficiently ingest your data into Redshift. Our Redshift cluster has got the data for the last 2 days and enables us to perform complex and powerful queries over this very large data set. Let's find out what the most popular drivers are of tweets about Mars. So we see some words that are not so surprising: curiosity, space, rover, NASA, India, because India just launched a mission to Mars. And then we start seeing some more interesting trends. Things like rock, not necessarily a Mars rock, performance, concert, gorilla. Ladies and gentlemen, the biggest driver about tweets about Mars, Bruno Mars. Turns out that people weren't tweeting about my favorite planet. They were tweeting about Bruno Mars, the singer. We used a Kinesis app to connect to Redshift to discover the correlation by querying our historical data. Let's continue our data exploration. I wonder, what can we tell Bruno Mars about his fans by using this big data platform? Where are they tweeting from? Let's use the RDS Postgres database to find out. Let's query all tweets about Bruno Mars and render them on this map here. Turns out that Bruno's got fans all around the country, especially the West Coast. Think of all the complex GIS queries you can do by connecting your Kinesis apps to Postgres GIS. Amazon Web Services provides a variety of building blocks that let you do all kinds of interesting things, from Mars exploration to big data analytics, or both. We just saw how you can use Kinesis for real-time streaming, DynamoDB for real-time analytics, Redshift for warehousing, and RDS Postgres for GIS and powerful full-text queries. My colleague Dave and I built this app in less than a week. It processes tweets in real time, performs analytics, and costs about $5 an hour to run in production. Imagine what you can do with your data. AWS lets you build big data applications like this quickly while doing the undifferentiated heavy lifting, so you don't have to. Thank you.
Yeah, if you want to know more about that, please stop by the AWS booth to get the details on Kinesis if that's what you're interested in that. I hope that we gave you a bit of an idea what are the sort of the dimensions in our world that if we innovate and use our power of invention against those dimensions, that will help you forever. Also, I think we launched today in my keynote a number of very exciting new services or improvements, for example, to our collection of instances. Postgres, I thought it definitely got an applause for you guys, so I'm pretty sure that we meet some needs there. All the way over to Kinesis, which is of course a very new service where you may have to wrap your head around exactly how that can help you power your real-time applications. So that sort of comes close to the end of my keynote here. If you're not sick and tired of me yet, this afternoon I'm doing a number of fireside chats. First with technical founders of young businesses, so with Elliot Horowitz of MongoDB. I'll talk with Jeff Lawson from Twilio about how to build APIs as a business. And Valentino will give you great stories about how they're using DynamoDB. And then later in the afternoon, I'll be talking to a very illustrious set of sort of folks involved with startups. David Cohen, Ash Fontana from AngelList, and Albert Wagner from USV. With that, actually, there's one more thing. Yeah? Tonight, at 8 o'clock, in this room, we will have a really, really mega party with a very, very special guest. More than happy to announce for tonight, our 244th announcement. That much tonight at 8 here in this hall. I'll see you there. Party on. Thank you.
Ladies and gentlemen, this concludes the 2013 AWS reInvent Keynote program. On behalf of Amazon Web Services, we thank you for attending. Please join us tonight at 8 p.m. for fun, food, games, and music at the Replay Party right here at Hall D.